In this video, we are going to talk about identifying real numbers. Now, a real number is a number that is either categorized as rational or irrational. Now, let's start with irrational. Now, that's a real number that can't be written as a ratio of two integers. So you can't make it 2 over 4, 16 over 7. You can't make it 1/10, anything like that. Examples of those: square root of 7, pi, square root of 3. You might recall that those decimals keep going out, and they don't have any pattern. They don't repeat themselves, okay? So you can think of those as decimals that are non-repeating, never-ending decimals. So then let's jump to the ones that might be a little more familiar to you, rational numbers. Now there's a little picture here that is pretty helpful, okay? Examples of rational numbers, because they are a ratio of integers, are 1/2, 4, -2, 0, 1/10, 1/8, any decimal value that stops and ends or repeats. Some examples that would just fall in this outer ring are 1/2, 1/10. So that would be just, we would say, a rational number that is a real rational number. Examples of integers are the ones we see here: 4, -2, and 0. So I've made a little list here. The dots to the left and the dots to the right mean it gets progressively more negative to the left and follows the pattern here. It gets more positive to the right and follows that pattern. So this is numbers like -7, 8, 2, 4, 0, 6. Those are all integers that would fall in this circle. Now you'll notice that our whole numbers only continue to get larger. So they start at 0 and then count upward: 1, 2, 3, 4, 5, 6, 7. So that's this set. Yes, they are integers as well, but we consider the whole numbers starting at 0 and increasing. Then our natural numbers, they're sometimes called counting numbers. Those are the numbers that we originally count with. Think about when you were little and you first learned about numbers, you started counting with 1. And those are the natural numbers. You'll see that they're in the whole numbers, but they do not include 0. So let's look at identifying what a number is. So which of these are real numbers? And then for the real numbers, let's classify the type. So the first one, square root of 5. Well, that is a real number, yes, but it happens to be irrational. We can't classify it any other way. We don't have a good decimal value that ends. The decimal doesn't repeat. If you were to throw that into a calculator, you would see that decimal would fill up the screen, and if you had a chance, it would keep on going. The next is an example of a number that is not real. This type of number you might have learned somewhere in algebra or an algebra class. That's an example of an imaginary number. Anytime you have a negative under a square root, we can't classify that as a real number anymore. So that's not real. This next number is a real number. It's a perfect ratio of two integers, the integers 1 and 4. 1/4 is a real number that we consider rational. Now, -2 is a rational number because we could write it as -2 over 1. So that's the ratio of a two integers we were talking about. It's actually an integer. It falls in this list right here. So yes, it's a real number. It's a rational number. It's an integer. But it isn't a whole number because it has a negative there. What about 9/10? In E, that is a real number that's rational, but it doesn't fit any of these particular categories. So that's all we say. And then finally, F has a big list. The number 5 is real. It is rational because we could write it as 5 over 1. It's on the integer list. It's on the whole number list. It's on the natural number list. So that's one of those ones that fits many categories. So that is a little bit about how we identify real numbers. Thank you for watching. Have a great day.